All right, this is Mrs. Ford back again to continue talking about pollination. So this is pollination part 2. We left off just talking about the difference between self-pollination and cross-pollination. To give you guys a little bit of a refresher, cross-pollination is when two plants are needed in order to create an offspring. So the pollen from one plant is connected with the ovule or the egg in a separate plant, and that combination creates a brand new offspring that has new genetic material. Self-pollination, on the other hand, is where a plant has both the male and female reproductive organs, and it's able to pollinate itself. Therefore, we can expect that the offspring will be a genetic clone of the parent plant. Okay, so Mendel did a couple different experiments. We're going to talk about the first experiment here. This is where he cross-pollinated two pea plants. And when he cross-pollinated these plants, he made sure that they had different traits. So as you can see here, one of them was purple and one of them was white. So if you look here on the right hand side here, you have a little diagram. So he took the pollen from one flower, transferred it to this flower, and it connected with the ovule or the eggs, and then it produced some offspring. Okay, so he noticed that all of the offspring in this first experiment were all purple flowers. I want you to go ahead and pause the video here, and I want you to think about how that could have happened. We have one purple flower, one white flower, but all of the baby flowers are purple. How come we didn't have any white flowers? So go ahead and pause the video and discuss. Okay, so you guys should have a similar diagram that you have included in your notebooks. This is just diagramming out Mendel's first experiment. So, like we said before, Mendel took one purple flower, one white flower, and he cross-pollinated them. So we took the pollen from one flower here, and we connected it with the ovule or the eggs in the white flower here. We call these offspring the F1 generation. You can just remember number 1, it's the first generation after the parents, right? So the F1 generation. And again, we saw that all of the offspring were purple. And not really what we would have expected, not what Mendel expected either. I'm sure he was a little confused as well. Why didn't we get any white flowers? Okay, so that leads us to Mendel's second experiment. So he just got done with the first experiment, and he was like, okay, all of these flowers, all of these baby flowers are purple, right? He's like, I'm not quite sure why, but let's roll with it. Let's keep going with it, right? So he took he took the offspring from that first generation, so all of the purple baby flowers. He let them grow, let them mature, and then he self-pollinated those flowers. So Mendel then self-pollinated the offspring from the first generation, and he noticed that the offspring had 3 purple flowers and 1 white flower. Okay. Again, go ahead and pause the video right here. See if you can discuss with a partner why you think we got 3 purple and 1 white flower. Okay. So you should have a diagram that looks similar to this one here. This is Mendel's second experiment, which we just talked about. So this purple flower here, this is one of those original baby purple flowers from the first experiment. Okay, so from the first experiment, just to refresh your memory, Mendel cross-pollinated a purple flower and a white flower, and then all of the baby flowers were purple. This is one of those baby flowers. Then he took this baby flower and he self-pollinated it, meaning he took the pollen and the eggs from the same plant and he created an offspring. So the offspring in this second experiment we call the F2 generation. So it's the second set of offspring. And when we self-pollinate, we talked about this a little while ago and even earlier in part 1, when you self-pollinate or when a plant self-pollinates, we don't have any other flower's genetic information being included in this equation, right? So it's just the pollen and the egg from this flower. So we would expect that all of this flower's offsprings are going to look exactly like this flower, and this flower is purple. All right. So again, the question is, why did we end up with this white flower? Well, this led Gregor Mendel to discover parts of heredity and discover that certain traits are dominant and other traits are recessive. So the ratio that he found of purple flowers to white flowers was 3-1. So for every 3 purple flowers in that second F2 generation, we had 1 white flower. Now, 3-1, obviously we have more dominant purple flowers and we only have 1 recessive flower. The way I like to remember the difference between dominant and recessive, so you think of dominant trait, the dominant trait being like a big bully, right? A big bully in school, he pushes everybody around, he gets his way, and anytime we have a dominant trait present, anytime the dominant guy is around, he's going to make himself known. So if we have a dominant trait and a recessive trait, and we know that, well, all the purple flowers are dominant and all the white flowers are recessive, and we have a purple and a white trait, the dominant trait's always going to win out, right? Because he's the bully. He's going to pick on that white trait. He's going to pick on that recessive trait and be like, no, I'm going to be the one that shows up. This flower is going to be purple. Go get your own flower. And he's going to kind of pick on him a little bit. So this dominant trait is going to essentially take over whenever possible. And we're going to see why just here in just a moment. Okay, so here's both experiments kind of laid out, making it a little easier to see. Here's that first experiment. Mendel took a purple flower and a white flower and he cross-pollinated it, taking pollen from one flower and connecting it with the ovule or the eggs of a different flower. All of the flowers in that first generation were purple. And then he self-pollinated these flowers. So he took the pollen from this plant, connected it with the ovule or the eggs in the same plant, and then created a new set of offspring. This is the second generation of offspring. And we see here that we have 3 purple flowers that are dominant, and we have 1 white flower, which is recessive. Okay, so here's what he observed. A lot of what we just talked about. So, when the parent plants produced offspring, one of the traits would disappear. When the first generation plants produced offspring, that trait would reappear every 4 or so offspring. So what this means is, in that first generation, when he crossed the purple flower and the white flower and all of the offspring were purple, the trait that disappeared was the white color. We didn't have any white flowers in that first generation. However, then we would take that first generation, self-pollinate them, then we would see that white trait or that white flower reappear in every 4 offspring or so. Again, for every 3 purple flowers, we would have 1 white flower.